First up is the heating water system. The heating water system is pretty much all up on the 20th floor in the the penthouse mechanical room. And there's also some heating water devices down on the ground floor in the basement. There are 4 boilers, Wiesmann boilers that we're communicating with. There is a cogen with a heat exchanger to provide heat. Actually, the cogen is the first stage of heat, and the boilers are designed to make up the difference, if the cogen isn't satisfying the loop. These are providing heat to the domestic hot water. So there are 6 tanks of those, which we're just showing as 1 tank. But there are 6 individual domestic tanks. And then also the heating loop, the secondary loop here, which provides heating to the building at all the hot water coils. There are several sets of pumps. Each are doing their own thing. So there are pumps 3 and 4 are the chilled water pumps. 5 and 6 are the secondary system pumps, which these are operating kind of strangely right now because we're doing that water balance. I think this might be in hand here in the penthouse. 7 and 8 provide heat to the domestic tanks to heat the domestic. 11 and 12 provide the heat to the heat exchanger, or basically recirculate the water and inject the heat from the cogen heating loop into the heating water loop. 13, 14, not sure what that is, but 15, 16 are the domestic recirc pumps. And then there are more pumps down on the basement floor for the snow melt system. So the general idea here is there are 2 modes of operation: winter season and summer season. And basically all that means is, are we providing heat to the building or are we not? So during the winter, these pumps run and provide heating water to all the heating water coils in the building. This is the temperature that we're supplying, and this is the temperature coming back. Typically, it'll just be 1 pump. Well, not typically. The designs just have 1, so that only 1 will ever run. If the lead pump fails, the lag pump will kick on. So right now, pump 6 is technically the one being commanded on. If for whatever reason there was an issue, this pump isn't coming on, within 10 seconds, the other pump would kick on to satisfy the demand. They modulate their speed to maintain this differential pressure, which is what we're trying to find out right now through balancing. So when the balancer is all done, they'll tell us basically at full load, what our differential pressure is, and that'll be what the pumps will modulate at their variable frequency drives to maintain. This valve right here is pretty important. This basically isolates the rest of the building from everything in the penthouse on the supply side. So in the summer, this closes to shut off the heating water, and during the winter, this valve opens to provide the heat to the building. This valve here is our differential pressure bypass valve. So that is programmed to open if the differential pressure in the system goes too high. So the pumps modulate to bring our pressure up to set point, which is currently 4 psi, and right now we're almost there. So they think they're maintaining, but they're not actually, because they're in hand up at the penthouse. And if that pressure went too high up over our set point here for the bypass valve, this valve will start to crack open, try and relieve that pressure in the system. Pretty much always, you're never going to see this valve modulate open. It's only overridden closed right now because when the pumps were first put in hand, the pressure went up and this valve started to open to relieve that, and we don't want any flow going here for the balancing. We just want it all to go out in the system, so that's why it's over and closed right now. The active set point is being reset from the enable set point, which is currently set to 70, down to 20 degrees outside air. So at 70 degrees outside air, we are at 100 degrees supply, and as the outside air starts to drop down to 20 degrees, the supply temperature set point starts to increase up to this point, which is 150. When it's really cold outside, we'll have roughly 150 degree water, and when it's warmer outside, we'll have 100 degree water. And as the outside air changes in between there. Changes in between our enable set point and our lower set point, 20 degrees. It'll fluctuate between 100 and 150 linearly. Once the outside air goes up to 7 degrees, that's when we switch over to our summer mode and disable the heating in the building. Right now we're just overridden into winter mode to provide so that this valve would stay open for the balancing, but typically, because we are over 70 degrees, so we are shutting off the heat to the building. So under normal operation, this valve would actually be closed, the pumps would be off, and this would say summer here. The system in the building is designed as a 4-pipe system, but anytime we could have both heating and chilled water available, or either one of the two. There's actually an overlap right now, so the heating system kicks on at 70 degrees, and the chilled water system kicks on alternatively at 60 degrees. So above 60 degrees outside, our chilled water is available, and below 70 degrees, our heating water is available. So we have a 10-degree window there where we have both available. That is available to all the apartment fan coil units, and also the 5 air handlers and the 2 ERBs. Everything is piped, 4-pipe, with both of those available. I talked about that lead lag system here. Those pumps will alternate every week on Tuesday at 9 a.m. We chose Tuesday at 9 a.m. because that's typically a time when people are in the building. There's no holidays, usually every year, not like Monday has holidays, or it's not on a weekend. So if there is an issue with a pump or something, Tuesday is usually a pretty good day for that. And like I said, at 9 a.m. so at mid-morning. That goes for every lead lag system. They're all going to alternate on Tuesday at around that time, and that's just to share the load between the two pumps so that they just last longer. And if there's an issue with one, then the other one will pick up the difference. 4 sets of pumps we see on the screen right here, 3 of them are doing that lead lag. That's 5 and 6, which is our secondary loop pumps, 7 and 8, which is our domestic heating pumps, and 11 and 12, which is our cogen pumps. So only one of those will run at any time. 15 and 16 are CERT pumps for the domestic hot water, so both of them run. One, basically they do half the building each, so they both need to be operating. Like I said before, cogen is technically the first stage of heating. So when our heating system is enabled, the cogen runs to maintain this temperature, this active set point. If it can't do that within half an hour, that's when we enable the boilers until the boilers go ahead and fire. The way the cogen provides heat to the loop, it has its own system here that is circulating water here. We show this valve here, but actually at TCogen's request is disconnected and never modulates at all. It's just we always have flow 100% through the heat exchanger here. So it recirculates its really hot water here, and then the actual heating water is on the other side of this heat exchanger. We circulate water here. We always need, whenever the cogen is running, we always need water circulating here to relieve this heat from the cogen, because it generates a lot of heat. In fact, up to 200 degrees. So whenever it does get up to risk becoming steam, it shuts itself off. So it has a bunch of safeties and everything to make sure that it doesn't damage anything, vaporize all the water in those pipes. What you'll see is if either of these 2 pumps here, 11 or 12, aren't running, the cogen will trip off on high temperature. So one of these needs to be running in order to relieve that temperature. Right now the cogen, like I said, isn't running. It's enabled to run as the first stage, but it's not on. And I believe it's because it's manually turned off at the local panel. And TCogen is coming to look at that. I don't know if there's a gas pressure issue or something there. So that's the first stage of heat. If the cogen can't continue to satisfy this heating water, the boilers get enabled. So that's this point here. This boiler's enabled. They're actually always enabled. It's really just the set point we're giving them, whether it's lower than the current temperature or not. At that point, we enable the boilers and they fire. We really only enable boiler 1. Boiler 1 is the lead boiler, or the master boiler, and our hardwire enables for both the heating and domestic heating prior to boiler 1. It then communicates with the other 3 boilers, and they determine who should fire and based on runtime and all this. So all that logic is done in the boilers themselves. The BMS controls are really just to enable them and allow them to run or to lock them out. We have some interesting points here. They're all pretty self-explanatory as far as the boilers. This point here is to enable the heating, domestic heating. As our domestic, we'll talk about the domestic in a second, but as that temperature starts to drop, we enable the boilers and they fire up to 183. Otherwise, they just maintain the active set point here. So these two, the cogen and the boilers, are providing the heat to the building, which is following this set point, but also the heat to the domestic loops. So pumps 7 and 8 work to recirculate water through the water heaters, and this three-way valve here tries to divert the water as needed to maintain our average water tank temperature. So the way this works is we have a temperature sensor in all 6 water heaters. We take the average of all those and we try and maintain 140 degree water. As we fall below 140 degrees, that three-way valve starts to open to the heaters here to provide heat to them. And these pumps, one of pump 7 or 8, whichever is the lead, is designed to modulate up to provide more flow. We've found, the reason they're overridden right now is that we found that when the heating system is enabled, the water would rather, path of least resistance is these pumps here. They're much larger and the water just kind of goes here and not enough heat gets to the heating water system. So they're overridden to 100% just to ensure maximum flow through to maintain those domestic tanks. Once this valve gets to 100% and our tank temperature is still not at set point, we give it some time, and after 5 minutes, if that doesn't start to increase again, that's when we kick on the boilers for that domestic call. So as you can see right now, we've fallen, I think we fell down to maybe 130 degrees. We kick the boiler, we enable the boilers for domestic heating call, and that is what they're currently doing. So they're trying to heat these domestic tanks back up to 140. Now these tanks then provide the hot water to the domestic loop, which then mixes with the city cold water, it's really like recirculated domestic water to provide 125 degree water at all times to the building. These points here are coming from the brain mixing valve. It monitors the incoming water on the cold leg and the hot leg, and then it modulates itself to maintain 125 on the outlet here. That's what this valve here is supposed to be, this brain valve. BMS has no control over that. It's just monitoring to make sure that that temperature is always satisfied. These pumps, like I said, are always running. These are circulating the water, the hot water, so they always need to run, or else we won't have pressure and hot water in all the apartments for everyone. There are also domestic booster pumps in the basement. Basically take the water and shoot them back up the building. Again, the BMS has no control over those pumps. We're just monitoring that they're just running or not. And honestly, we have no idea when they're trying to run or not run. So the status point is just, well, they're running now or they aren't. The alarm point is a fault contact coming from their general controls. So if those controls ever go into alarm, that's what this alarm point is. Otherwise, for all the pumps, the alarm point is, we are commanding that point on, but we aren't getting status within 10 seconds. So then you'll see this alarm point go turn into alarm. That's for all the pumps. If it's the other way around, notice here, we're not commanding this pump on, but it's on. That's not technically an alarm, but it's definitely something that needs to get looked at. I think they must have it, through balancing, they're messing with the pumps there. Some of these pumps, the ones with VFDs, have a fault contact. Basically, if there's an issue with the variable frequency drive itself, whether it's overheated or it's out of phase, there's a bunch of different faults for those. If there's an issue with the VFD, this will go into fault, but typically, if there's a fault with the VFD, the pump, it's also going to be an alarm. So kind of redundant here, but it could be good to know. Basically, if a pump goes into alarm, you have to go up to the penthouse and check it out. Maybe it doesn't have power. Maybe it's, maybe maybe something's mechanically wrong. So those are the main alarms that are kind of available here through the boilers, cogen, the pumps. Also with the heating system is, well, maybe we'll do a different, well, it's not that much. The snow melt is part of the heating system. So that hot water supply also goes down to the basement. There's an injection valve that, when enabled, maintains 110-degree water here. We inject heat to this heat exchanger and we circulate water here, try to maintain 110 degrees for the snow melt systems. When the slab temperature, so there's 3 zones outside, the rear driveway ramp, the side building ramp out to Green Street, and then the main entrance ramp right in front of the main entrance. If any 3 of those, there's a temperature sensor and it's a combo temperature and fluid sensor, or a hydron, I don't know what the word I'm looking for here, but moisture sensor, yeah. There's one per zone, and if that temperature drops below 38 degrees, then we enable all 3. We enable that system effectively. So typically you'll see that all 3 of them are enabled at the same time, but technically they work independently. So we enable the system. They have their own separate controls by Viega down in the basement. If that system then determines that they need to melt snow, kind of based on that moisture sensor, they kick their recirc pump on for each of their independent loops, and that's when we kick on one of these 2 pumps and inject heat to the heat exchanger to maintain 110 degrees here. Again, these 2 pumps work, only one of them works at a time, and they alternate weekly. If one fails, if the lead fails, the lag will come on. So they're really just to provide that 110-degree water, and then each of the 3 zones provides their own, modulates a 3-way valve of their own with their own pump, and tries to heat their slab up to set point, which is set locally at all those controllers. The idea is just to make sure that ice doesn't form on these ramps for people. This supply temperature is reset based on outside air temperature. Currently it is 76 degrees outside, so we are at the lower point of that reset. The outside air, so the chilled water system is a little simpler than the heating water system. Notice we don't have, we don't have to worry about domestic heating and cogens and all that, so it's more of a dumbed down loop system. A lot of the same kind of ideas work for the chilled water as for the heating water though. So again, we have these 2 pumps here. I guess they're 9 and 10. So there were 3 and 4 earlier. So pumps 9 and 10 up in the penthouse are the chilled water pumps. Of the 4 big, floor mounted pumps, they're the 2 on the left, and the heating water pumps are the 2 on the right. When you're out facing the chillers in the mechanical room. Again, they're designed for only one of them to run at a time. Right now we see that they're both running, but that's just because of this balancing, that they must have both working together. So similarly to the heating water system, we are enabling this system based on outside air temperature. It's when it gets hotter, obviously, so we need cooling. So when the outside air is above 60 degrees, we enable the system, and when we're below 60 degrees, we disable. The supply temperature is shown here. Actually, it's pretty high right now, and that's just an alarm. We have that disabled right now, the actual alarm, but that's just because I think we have all this heat transfer through the balancing, so all the heat for the boilers are kind of transferring to the cooling. I mean, honestly, we should probably... The system's not designed to run exactly how it's running right now, but fortunately for the balancing, that's how it is. The supply temperature is being reset based on outside air, just like the heating water, but it works a little differently. So when we first enable at currently 60 degrees, we are at this high point of the reset, so we're trying to maintain 49-degree water supply. Once that outside air temperature rises up to 75 degrees, then we start to decrease our supply temperature set point down to this point here, 42. So we will reach 42 degrees set point once the outside air goes from 75 to 85. So at 85 degrees outside air and above, we're at 42 degrees. At 75 degrees and below, we're at 49. And in between, we're just kind of floating between 42 and 49. The idea is, we don't need that cool water when it's not as hot outside, but then when it's hot, once it's hot, we need to make sure we're providing enough cooling. This is another instance here where our communication is down. So notice this chiller, all these points are yellow, but it's just for chiller 1. So that kind of tells us that, hey, looks like there might be a communication issue with just chiller 1, and that's because it's powered off and kind of deconstructed up on the roof there. But if you'd come here and saw this and both chillers were yellow, then now there's an issue with both chillers, so that means both of them must have lost power or something. If you'd come to this page and the whole page was yellow, including both chillers, then we've also lost communication to probably the whole penthouse, because that would be this chilled water control of both chillers, and you can check the heating water system to make sure that that's communicating as well. So the way these work, both chillers will be enabled at the same time based on demand. So when we enable the system initially, only the lead chiller runs. Once that chiller capacity is over, I believe 90% for a certain amount of time, and we still aren't at set point, then we enable the second chiller, and they both run together. So they're both there available if we need them. Otherwise, just one of them runs. The two pumps over here are, again, maintaining this differential pressure set point, which is here. Maintaining this differential pressure to this set point, which will be set by the balancer. So they modulate their speed. One of them runs at a time, and it modulates its speed to maintain this set point. So notice, they're in hand, and we're above our set point here. The pressure is 8. We're above set point 7. So these are at minimum speed because they're trying to slow down to relieve the pressure, but we're not getting there. This valve works just like the heating water valve, where if this pressure goes above this DP valve set point here, this valve will start to open to try and maintain the higher of these two set points. But again, you typically probably won't see this open, because if we're enabled, we probably want cooling in the building, and there's probably enough valves in the building open to not have a high pressure in the system. Differential pressures for the heating and the cooling. I guess I didn't talk about this with the heating system, but they are really the only sensor for both that are outside of that mechanical room. They are down on the second floor, right outside the stairwell that connects to CHA's main office. If you walk out the stairwell door, you take a step forwards and look up and move the ceiling tile or whatever. Both differential pressure sensors are right there, so if there's ever an issue with the differential pressure, that's kind of the first place to look. It's a very important sensor because it determines how fast the pumps are moving, and they could either run too fast or too slow, and either of those can cause issues. So DP the differential pressure is an important sensor. And again, those are on the second floor right outside the stairwell. And again, there's not much more to this system. We're communicating with the chiller, so all these points here are coming from the chiller just to kind of as a status. But otherwise, we are hardwired to enable them, and they go ahead and run, and then they modulate their own to maintain temperature. This chilled water goes to all the fan coil units and the 2 ERVs and all 5 of the air handlers, so everything in the building besides just the heating equipment gets this chilled water. Now that we've talked about the heating and the cooling, move on to the next major systems that feed a large part of the building, which are the ERVs, the energy recovery ventilators, or you'll hear me say ERV or energy recovery units, or basically just air handlers up on the roof that provide 100% outside air and 100% exhaust to the building. They're not really large units, surprisingly, for the amount of space that they cover. They're kind of like a walk around, but they're not humongous. But there's 2 of them. They're on either side of the roof by the stairwells, and they provide fresh air down to all of the apartment spaces and into all the hallways in the apartments. The one that serves half of the Half of the second floor is also apartment spaces, so one of the units, the unit on that side, which I think is ERB2, provides a stairwell 2 maybe, or B, has that extra little bit on the second floor. Otherwise they are pretty much identical. They provide fresh air. I think they provide some air into the hallway, and then also there's a little grill into each unit, which provides a minimal amount of fresh air to each apartment unit. And then the exhaust pulls from both the kitchen and the bathrooms, exhaust that out of the building. So it also provides a little circulation in the units, so air doesn't get too stale in there. Like I said, it's 100% outside air, so the air supply stream pulls from the outside air through this outside air damper across the energy wheel, across both coils, depending on whether we're heating or cooling. Piece of the active fan then blows that down into the building. Talk about each piece of equipment in a bit. The exhaust stream pulls from the building through the return air damper, across the wheel, and then out of the building. Might be backtrack dampers or something here, just to, if the fan wasn't running, they gravity, they close, but otherwise they get blown over by the fan. The units, because the building is always occupied, the units are a 24/7 operation, so the fan should always be running, the damper should always be open. If the wheel turns off kind of in this shoulder season, this damper needs to be open in order for the fan to run, or else we'll basically deadhead the fan, pull from a vacuum here. So this damper needs to be open. We're monitoring the end switch with the status of the damper with an end switch. The same with the return air damper. It needs to be open in order for this fan to run. And then we are wired to the VFDs on both the fans to enable them and give them a speed signal. Based on balancing that just happened recently, the units are just going to run at 100% speed in order to maintain the design flows, which we are monitoring here. So I think before we had them kind of modulating to maintain flow, but after balancing, it's been determined that they are meeting their design at maximum speed, so that's what they're basically going to be left at. So again, we have those flow stations to ensure that we are moving air and providing and exhausting that fresh air. The temperature that we are providing to the building changes based on the season. So when it's cold outside, when it's warm outside, like it is right now, which warm is basically anything above 65 degrees, we provide 55-degree air down to the building. And when it's cold outside, we turn to heating mode and we provide 72 degrees air to the building, and this will reset in between the two based on our outside air. Like I said, the wheel just operates all the time. It's not a heating or cooling wheel, it's really based on what season we're in. So if it's hot outside, if it started to get hotter here, we have this hot stream of air coming in here, but we're trying to get 55-degree air set point. So the idea is take some of that heat, transfer it onto the wheel, and cool the wheel using the cooler return air. I guess, like I was saying, right now our return and our outside air are pretty much identical. We're not really gaining, we're not really doing much with this wheel. But as it starts to get really hot out, we're really cooling the wheel and cooling this input stream with the return air, and vice versa. When it's cold outside, we're heating up this the supply stream with the return air. You really see a good amount of energy transfer when it's really hot or really cold out. This is basically the first stage of heating and cooling. And then to bring our temperature to set point, we modulate the heating or cooling valves based on what's needed. So right now they're both open for the balancing, but otherwise normally bring the temperature down to set point. We'll modulate the cooling valve to maintain the 55 degrees. And in heating season, we'll modulate the heating valve to maintain the 72-degree air. Provide neutral, air or kind of cool air in the summer to, keep the space comfortable for all the tenants. There are some alarms that are being monitored as well. So there's a freeze stat on the coils here. So basically, if the wheel isn't running and there's an issue with the heating water system, you might see that the freeze stat trips. Really just to protect the equipment in the unit, and also we don't blow really cold air down into the building. So if we have a failure of some of this equipment here, of the heating equipment, the freeze stat trip I believe the freeze stats are auto resets, so if they do trip, we'll automatically reset. As long as the heating system is always enabled and everything, we won't see the freeze stat trip too much. The system is glycol, so there isn't too much of a concern as far as freezing anything, but you don't want it to trip off. You always have to be careful with really cold temperatures and these liquid systems. Tied into the smoke, the fire alarm system. So if you get a signal from the fire alarm, the smoke detectors in the unit, freeze stat will shut down the unit if it trips. The whole unit will shut down. The dampers will close. The fans turn off. Likewise for the smoke detectors. If any of those trip, fire return. If there's a signal from the fire alarm system, shut down. The system will shut down. Next two alarms are for the supply fan and the exhaust fan. Sorry, it just kind of started raining here, so you might start to hear the rain in the background. Exhaust fan, if they are commanded on, but we don't get status within that 10-second window, they will go into alarm, and they'll be showed here. That might happen if there's an issue with the VFDs. If there's an issue with the VFD, I believe those need to be manually reset at the drive, so that's something that definitely wants to get monitored. Make sure you need to monitor to verify that we are getting that fresh air to the building. There's an alarm just for the dampers. Basically, if for whatever reason the damper fails and closes, we got an alarm that we're commanding it open, but it's actually not open. There's also an alarm for the wheel, so if at any point you command the wheel on and the wheel doesn't come on, then go into alarm. The last two alarms are for the filters. As you can see, one of the filters is an alarm right now. So it's just a piece of equipment that is just a device that's monitoring the pressure across the filter. And if there's too much air pressure, a significant pressure drop across the filter, then that filter must be dirty and should be replaced. Through construction, they were getting dirty pretty quickly. Now, as construction comes to a close, they should last longer. Now that we are running our fans at a higher speed as well, that's creating more pressure in the units, so that's also kind of affecting these pressure switches for these filters. These were filter monitoring devices provided by the manufacturer. That's what we're wired to. So if the manufacturer is saying that the filter is dirty, that's what we're reporting. Like I said, there are two of these units, and they work identically. So it's always good to verify that both are working and operating properly. But if you've seen one, it's pretty much the same as the other. You get slightly different values for everything, but pretty much identically on the graphics. They should both always be running